G'day chemists. So welcome to video 8 in our IB question of the day series. We're hoping to put up one question per day in the lead up to the chemistry exam. So this one we're moving away from what have been our multiple choice questions, and we're moving into a shall we say longer response, but we're still just dealing with a small chunk. Again, our focus here is like the ability to sort of pop in while we're doing other stuff. Just let's see what this one question is, bash it out, and then move on with our day. Okay, so alright, so here's our question. Don't forget to pause the video here and have a crack at answering it, and then we'll go through both what are the marking criteria as well as what a sample answer would look like. So our question is, alkanes are commonly occurring organic compounds. The first 4 straight chain alkanes are gases at room temperature, but explain why the boiling point increases from methane to propane, which is actually the first 3, not the first 4, but what else? Okay, so let's have a look. Alright, so hopefully you've had a go at answering this question. We'll look at the marking criteria first, then we'll look at the sample answer. Alright, so explain why. That means we need to, again, sort of name it, describe what is happening, and then give an implication of that. Okay, so the first thing we need to do for Mark 1 is we need to name in our answer London dispersion forces. The marking criteria that the IB give us is not enough to go dot point. Like you need to actually, say, so you can't go London dispersion forces, boom. You need to write about it, explain it. But the first part needs to name London dispersion forces, and then we need to talk about how the size of London dispersion forces increases, and therefore the boiling point becomes higher, as the number of electrons or the size of the electron cloud increases. Okay, so name it, describe the relationship, and then the implication for it. So therefore the boiling point increases. You want to link it back to the data in here. That's going to be important, right? So you want to talk about boiling point, number of carbon atoms, length of the carbon chain, something like that, where you're talking about this. You don't need to quote the numbers on the data, but you need to talk about, these are our independent and dependent variable. So this is my sample answer. Straight chain alkanes experience London dispersion forces, brackets LDF, so you don't have to keep writing it, as intermolecular forces. Alright, so we're saying there's intermolecular forces between the molecules. As the length of the carbon chain increases, we've referenced this number of, here, the number of electrons increase and the attractive strength of LDF increases. Okay, so this is what's happening. Therefore, the boiling point increases as carbon atoms increase. So we're talking about here, we're talking about all of that, and we've referenced, the data. We've explained, which means we've named it, we've described it, and then we've given the implication. So this is M1 over here, which is this. This is M2. All right, so let's look at some key takeaways. What are the things that we need to be thinking of when we think of a question like this? First, M2 is dependent on M1. You can't get the marks for this one without talking about it being London dispersion forces. At least that's my understanding, and every time we talk to the markers. And 2, we want to remember what explain is as a command verb, right? So the explain command word requires name the relationship, describe the relationship, impact of the relationship, right? So it's all 3 of those things, and that's done right here. Okay. All right. If you have any questions, put in the comments below. If you're one of my students, just send me an email. We'll get back to you as quickly as we can. And thank you for watching. Don't forget to subscribe so you can sort of catch all the questions of the day as they keep popping up as you move forwards towards your exam. If you're a teacher, feel free to send these out to your students. And yeah, we'll see you next time. See you tomorrow. Bye now.